Hi, everybody. Welcome to the Experimenta series here at Imagine Science. I apologize for the delay. We had a little bit of a computer technical difficulties, but we have everything going. We have all our backdrops. We're ready to go. I'm very excited to have today David Gallo, who's a friend, and he's an American oceanographer and also the director of special projects at the Woods Hole Oceanographic Institution. David, thank you so much for being here.
You're very welcome, Alexis.
So, I wanted to talk a little bit about, we're very interested, with Imagine Science and talking a little bit about kind of the intersect between, scientific research and imaging. But maybe you could start. You're quite an activist out there in terms of our unexplored oceans, and I was wondering if you could just talk a little bit about what exactly you do on a daily basis.
Sure. Well, on a daily basis, that's a good. A lot of people ask the very question. It's part of what I do. Woods Hole, to begin with, Woods Hole Oceanographic Institution. We're a private, not-for-profit think tank, ocean think tank. There's about 1,000 people that work at Woods Hole, so we're about really the world's largest independent laboratory. And we study everything about the oceans, and because 70% of this planet is covered with ocean, we pretty much study this whole planet Earth. And specifically, we want to know about the oceans and the impact on humanity and the impact on the oceans. So a lot of what I do is try to, one, raise awareness about, one, that the oceans are unexplored, and we need to explore our own planet. We've explored about 5% of what's out there, so we need to really explore Earth. And when we do, we find amazing things. And two, we need to learn how to protect the ocean so that we can leave this healthy planet for generations to come. So I have a duality, a twofold purpose. One is the exploration part, and the other part is the awareness that we need to take care of the oceans, and that the oceans will take care of us.
And David, so explain to us a little bit what would be, besides kind of being actively involved in terms of, talking about, that we're so focused on kind of space exploration, and we know very little about our oceans. How do we begin to even tackle that issue about,
Yeah, it's a tough one because, as I said, 70% of the Earth is covered with ocean, and the average depth is about 2 miles. So it's vast, it's deep, it's inhospitable. If you get average depth 2 miles, you can't scuba dive or snorkel anywhere near there. So you have to have very specialized technology, and to do that we have submarines and robots and cameras and all sorts of other sensors that pretty much have to be designed by people doing the exploration. Those things just don't exist. It's tough to go to a place where it's been pitch black through eternity, freezing cold, and where the pressure is high enough that it would crush the Titanic the same way you could crush an empty paper cup in your hand. So technology is one of the big hurdles, and and also in the oceans we don't have GPS. Radio waves don't penetrate the sea, so we can't use GPS. We can't use radio waves, radios. We have to use sound. We have to bring our own navigation. We have to bring our own power. We have to bring our own lights. Everything that we take for granted up here under the sun, we have to create on our own beneath the sea. So it's pretty tough. But in the past 5 years, there's been a real revolution in the way that we can explore the sea. A lot more robotic exploration going on. There's still human exploration at the bottom. So we're entering sort of a new phase where things are coming a little bit faster than they did in the past.
And so David, so what have we? So obviously the ocean has this, these multiple layers, and it has mountains, it has lakes. How do we, what has been done in terms of kind of exploring kind of the depths?
You raised a good point, Alexis. People think that the ocean's a big blue fishbowl. But in the middle of the ocean, there's the world's greatest mountain range. It's called the Mid-Ocean Ridge. It winds around the Earth like the seams of a baseball. And that mountain range, 50,000 miles long, 70,000 kilometers long, it's higher than the Alps. It's got thousands of peaks higher than the Alpine peaks, and places as high as the Himalayas. There's underwater valleys, tens of thousands of underwater valleys, many times wider and deeper than the greatest valleys on Earth. There's underwater rivers. There's underwater waterfalls, underwater lakes, and more life in the ocean in places where we said there should be no life at all. We find more life than the tropical rainforest in diversity and density. So when we do explore in that 5%, we find it's an incredibly marvelous world full of all sorts of surprises, some of them revolutionary.
And David, could you talk a little bit about some of those, obviously for those people out there that are interested in kind of marine, marine life, could you talk a little bit about some of the marvels that you've encountered, or that you've, in your research that you've encountered, that's specific to?
Well, again, a couple of different things. I've been in this business now since about the late 70s, so it's been a while. So I've been very privileged to have been on a number of expeditions, and there are those moments out on the ocean or at the bottom of the sea in the submarine, or even using robots, where I won't call it an aha moment, but it's a moment where it's very deeply spiritual in many ways, or emotional, because you're seeing something that's never been seen before, maybe something that'll never be seen again. And it gets very personal when you're looking at an animal, and animals looking at you, and that's maybe the first and last encounter humans and that species will ever have. There's those kinds of moments. There's the other kinds of moments where you understand how wonderful this world could work by looking at how the world has changed over time through history. Everything to me is music. It's rhythms and pulses and cycles, and it's been going on at every scale over hundreds of millions of years, and over nanoseconds, and over millimeters, and over thousands of kilometers or miles. So it's wonderful how this planet can actually work. We really can figure this out. If we decide that we really want to do it, we can figure out how to live on this planet. But then there's moments where you just sit back, and I'm trying to enjoy more of those these days, and take it all in, and try to see this planet in the way that it really is. So not break it up into biology and physics and chemistry and all that stuff, but just the same way you would a symphony orchestra, instead of focusing on one or two of the instruments, to listen to the whole symphony and just enjoy it. And that's what I'm trying to do now, is to really take it all in and try to understand what's really going on here.
And David, so how have you, tell me a little bit about the position of Director of Special Projects at Woods Hole, and
Sure.
Have you been on these expeditions? I mean, are you?
Yeah.
Could you talk a little bit about some of these expeditions, like what's happening? What's happening today? What happened like this week?
Sure.
I'm very curious to get a glimpse of that.
Last week I was on the west coast of the U.S. Talking to various people about projects, and there were one or two events where we celebrated people's involvement in the ocean. There's an event I missed in San Francisco to celebrate. Wendy Schmidt has just launched an X Prize challenge to try to help us understand the chemistry of the ocean. The oceans are becoming more and more acidic, and that's a global thing, and it's not very good. It's worrisome, so we need to understand that. And Wendy Schmidt has jumped into the middle of that and helped initiate an X Prize to try to promote radical change in how we can understand the ocean. Let's look at my last couple of expeditions. One, I was co-leader of an expedition to Titanic. That was in the last couple of years, and that was the last expedition to Titanic. And the mission there was not just to make a documentary, but to actually, for the first time, make a real map of the Titanic, so that we know where everything is, from every pair of shoes and every light, every cup and plate, and we know where the big pieces of the ship are. So we can begin to actually manage that site, and over time. And no, you can't do something. In fact, this is a theme that plays through quite a bit. We can love this planet to death. We actually need to have the facts. So when we look at something like Titanic, instead of saying it's rusting away, it'll last 25 years, it'll last 2,000 years, we actually need to know what's there and what state it's in. Also, there was a plane that fell out of the sky June 1st, 2009 that was missing for quite a long time. It was Air France Flight 447, and I was co-leader of that expedition to find the remnants of that plane. And that was, Titanic was a tragedy, but it's removed by many, many years, 100 years, 101 at this point. And Air France was just a few years ago, so it really touches home about a modern day tragedy. So that was one of my expeditions. Getting ready to go, we're looking at doing an expedition with National Geographic maybe one of the most exciting we've done in a long time, to find the ship of Ernest Shackleton, and that's under the Antarctic ice in the Weddell Sea. So it's about the same depth as Titanic, about 3 miles deep, but it's under a ocean that's about covered with about 9 feet of ice, and it's a long way from any place. So that's something we're working on today. The other things I work on routinely is how to better make the case about this planet, this ocean, this species called humans, and how do we begin to get this right? How do we begin to, because the things we know now is that even though we're tiny, insignificant on the face of the Earth, we've managed to change the chemistry and temperature of the air and the seawater. And anyone with an aquarium knows, if you change the chemistry and temperature, you're asking for trouble. So we're trying to figure out just what that means, and part of what I try to figure out is how do we make this digestible for the public at large, because that includes me. I'm not an academic thoroughbred in many ways, so I like to have things put very simply. Here's what we know, here's what we don't know, here's what we need to know, and this is why we need to know it, and here's the consequences if we just don't do anything. So I'm looking at that quite a bit. In fact, that excites me. It's odd, you probably picked that up in my voice, that I'm very interested in talking to, in terms of climate, for instance. Climate's controlled by the oceans. Climate's about precipitation, and it's about temperature. That's all a water thing, where it rains, where it doesn't rain, how much does it rain. And so I want to talk to various groups: cattlemen, coal miners, fishermen, farmers, all the people that rely on the climate and the weather for their livelihood. I don't think I've ever heard anyone or never been part of any attempt to actually talk to these groups and let them know, what we don't know, and see what they think and get their opinion of because they've got a lot to gain or lose. There's going to be a lot of winners or losers in the future. So I'd like to get their impression of what's going on.
David, so you said something that also it got me a little excited as well about making the information digestible.
Yeah.
And how to communicate, this, to people that are intimately involved about this issue, but also to the wider audience. And I was just wondering if you could share, because that this is also a little bit what we do with Imagine Science, is that we use film and video and visual arts as a way of communicating science. How do you go about? I mean, obviously, you gave a TED talk, and you've been an active speaker. How do you get about in getting people's excitement started? How do you spark that excitement, and what are your sort of strategies for doing something like that?
Well, it always helps to be excited yourself when you're bringing the news to people, and it helps to have a platform to do that, so that, you could do it word of mouth, but that could take forever. What I find is that some of these discoveries, especially at the bottom of the sea, that one of those TED Talks, I think I've given about 10 TED Talks, and I don't know how many TEDx Talks, but even more TEDx Talks. The one that's number 3, it's been in the third or fourth all-time watched, is because of an octopus that changes shape and color. It's the work of Roger Hanlon. It's fascinating bit of video. It's great. And so I think some of these stories can have the opportunity to tell themselves, or just to be cool to look at. Delivering a message on top of that is often tougher. Titanic, for instance, you say Titanic and people get very excited about Titanic. When I give a presentation, if you add Titanic to the title, it almost triples the audience number because of the word Titanic. And that's great. Titanic's a great story, but if you want to message it, you've got to put a message on top of that. So a lot of what I do is try to give people what they want, which is the candy for the brain, which is the pretty pictures, the interesting stuff, Titanic, Shackleton, the octopuses and things that are incredible. But then on top of that, you've got to lay down, so what's it all mean? And for those that, I try not to overwhelm people with that, because some people don't care about that stuff. And so I'm not trying to force this on anybody, but for those that are interested and that need to know about the serious stuff about what's going on, well, I think there should be a story laid on. But story is the important point, not a pile of scientific abstracts or papers. You've got to really, I could talk about the important things in science, eddy viscosity of warm core rings in the Gulf Stream, where the percolation of melts through gabbroic carapace of the ocean crust. forget it. That's not what we need to know.
Hmm.
We need to know in very simple words, beginning, middle, end, what's going on. Tell me a story. And I think you can get a lot more people that way, and you know that as well.
That's really fascinating, and I have to say that all of the talks that I've heard from you and the TED Talks and the video component, I mean it's really exciting, and I also noticed that there's a lot of interaction. I mean, more than I'm kind of familiar with, but I see a lot of kind of exclamations or a lot of people that are interacting from the audience as you're giving these talks. I wanted to ask. Uh, what are the advances that have been made in terms of imaging the
Yeah,
ocean? Because I wanted obviously when you describe it and it's this beautiful kind of poetic and narrative about that the ocean has all these layers and it has waterfalls and it has lakes, but how much have we advanced in terms of being able to see that with a camera eye?
sure. When I first began in this, two things. One, you have to have a map because the ocean is pitch black 2 miles, when you get 2 miles deep, much before that too. And there's, as I said, mountains and valleys and all sorts of stuff. So you have to have a map. And in the days when I began in this, if you had a map, you could have something the size of a major city like Manhattan, and you wouldn't see it on those maps. So our maps were very bad. Today, you can see a Coke can at about 2 miles away. So our maps have gotten much, much better. So we know the shape and lay of the land. The cameras themselves, in the olden days, not very long ago, you would have sort of this bluish kind of hazy image of objects on the bottom or creatures on the bottom. And now today we've got some of the best 3D high definition cameras available, and multiple cameras too. And then we've got lighting that goes along with it. So the imaging stuff has come an awful long way in underwater imaging. And one of my closest colleagues, Bill Lang at Woods Hole Oceanographic Institution, builds some of the best underwater cameras on the world today. Jim Cameron's team does as well. And I think that gives you some sense, if you've been to the movies to see Titanic or any of Jim Cameron's documentaries or any of our work on documentaries, you'll see that the quality, it's almost as if they were shot in a field someplace under full sunlight. It's gotten very good. So we can actually now, and I love that because you don't have to explain, you don't have to say, well, so what you're looking at is, you can let people see it for themselves and say, well, what do you see?
Mm. And speaking about that, does a lot of the exploration about the ocean, does a lot of it happen where you film kind of a landscape that's underwater and then afterward you review it? I mean, is that kind of
Sure.
the way that you kind of do the topography of the land? I mean, or is it done kind of instantaneously as you're filming? How does that work?
Well,
Is
it's
there
very
kind of like
different.
a film screening that happens afterwards where you kind of look at what you've just shot?
Yeah. Well, it's a very difficult thing to image underwater. You can take a snapshot, or you can sit in one place and take video. But if you start wanting to look at a larger area,
Hmm.
for instance, on Titanic, you could see a porthole and take a picture of the porthole. But if you want to get some sense that there's a ship around here, you have to move the camera around. And just outside the range of the lights of the submarine, which don't go very far, or robot, it's pitch black. So you have to come up with some novel ways to mosaic many, many, sometimes thousands and tens of thousands or hundreds of thousands of images together to get a feeling for what you're looking at in the bottom. Video is a bit different because you're moving around in the submarine. So like any other video, sure, after a dive or a robotic lowering, you review the video, pull out the best parts, and then try to put a story together. On the ship these days, though, because the information, much of it, if you're using a robot, much of that information comes back to the ship immediately, so you have a whole team of people watching. I mean, on Titanic, I could walk out of my cabin, walk down a short hallway, and there in front of me in that control room would be Titanic live 24/7 in 3D. It was awesome that we could just had Titanic right there at our fingertips, so that was pretty cool.
And so David, so how deep has man been? Like, what is the deepest that we've been, like an actual individual, And how deep are our oceans? And
Yeah, well, individuals, I mean, there have been free divers. I mean, scuba, if once you get below 30 feet, you're starting to get serious already, but people have scuba down to 300, 400 feet. And then there have been free divers that have gone a bit beyond that, which is pretty amazing. Only one or two individuals. With the submarines these days, we're very comfortable working down to 6,000 meters, submarines and robots, and that's 95% of the seafloor, maybe even 98% of the seafloor is shallower than about 3 miles deep. But Jim Cameron, the deepest part of the ocean is about 7 miles. That's when you look up in the sky and see a jet with a vapor trail behind it. That's about 7 miles. So those are the trenches. It's a very small area of the ocean. Until you put them all together, it's pretty large. But in any given area, it's pretty small, a couple of percent of the ocean. But very dramatic. So to go from 3 or 4 miles down to 7 miles is pretty amazing. And only 3 people have been there. Don Walsh and Jacques Piccard went together many, many years ago, more than 50 years ago, in the Trieste. And recently, James Cameron, the filmmaker, by himself went in a submarine that he and his team built to the Marianas Trench. So it's only been visited a couple times by humans and really only a couple times by robots as well.
yeah, I can't stop thinking, David, about the also kind of the early science films that were made. I don't know if you're familiar with this series by Pondervé, the French oceanographer. He did a
I've
series
seen some of it, yeah. Yeah.
and
Well,
yeah.
well, I mean, it's those kinds of things. I mean, it's not for everybody, but I think it's those kinds of things, and we're not looking to. We're just looking for that little ignition to ignite the curiosity and to flip the switch, however you want to put it. And many, many people point to Jacques Cousteau, and in my field, say Jacques Cousteau began it all for them with the undersea world of Jacques Cousteau. And it's interesting because there was very little underwater footage in any of those shows, but it
Right.
was about the story, it was about the team. With me, the book Kon-Tiki, the book by Thor Heyerdahl, played a huge role in shaping my curiosity about exploration. I think most people, like me, thought that exploration, most of it, ended in the 1900s, early 1900s, maybe 1800s, that the planet's been explored. But the reverse is true. Most of it's unexplored, and exploration lives on. So one of the things we'd like to do is let people know that. But any of these films that get out there, because you have the distribution, the reach, to inspire people to learn more, and that's what we're looking for. We don't want every person to become a scientist or an ocean engineer, but at least it gives them some appreciation for what's out there and why we do what we do.
So David, so we're bringing people up to Mars.
Yep.
We're colonizing Mars. And would there be any science fiction, like films like Waterworld? Is that feasible that you could consider there being actual settlements and people living underwater?
Sure, if we had to, sure. I mean, it covers most of the surface of the planet. It would be tricky, but I think we're pretty smart sometimes as a species, and we could figure it out if we had to figure it out. But really what we should do is figure out how to live on land right now. I think about it that, like this map behind me, whenever I look at that map, a map of the Earth, there's 7 billion people living on there, and about a third of those people are really in pretty bad straits. They lack sanitary water, some lack water at all. And so they're clinging to the edge of life. On a planet that's mostly water, there's diseases, people that die from diseases that can be preventable. So I'm always very interested in looking at how we can help our own species right now instead of looking too far into the future. But if we have to move into the sea or move off the planet onto Mars, I'm sure we can do it. So the spending for space compared to ocean right now is about 150 to 1 in the government. So it's really lopsided. I'm not taking anything away from space. That's really cool, if you ask me, to be able to look at other planets and the like. But we do have an issue right here, right now, right on this planet. It's unexplored, lots of strange creatures, and it'll change our lives one way or the other, depending on what we find. So we ought to spend more time here at home too.
That's really great, David. I wanted to finish maybe by asking you if you were um, if this was kind of like an elevator pitch where you had to explain to somebody the main reason why we need to explore our oceans, like why is
Sure.
it important to explore our oceans? What would you tell that person that
Yeah,
says,
the
oh, I have
oceans.
no, yeah.
Oceans are unexplored, but what we've seen, we now know that the oceans are responsible for the air we breathe. About every other breath of air you take, you can thank the ocean for that oxygen. The air we breathe, the food we eat, the water we drink, most of the rainfall on this planet comes out of the sea. Where it rains and where it doesn't rain is controlled by the sea. No matter where we live, the oceans impact our everyday lives through things like weather patterns, hurricanes, floods, droughts, tsunamis. That's an ocean thing. No matter where we live, we have an impact on the ocean. Whatever you put on your backyards and your fields and your streams eventually makes its way out to the sea. So we have an intimate relationship with this unknown thing on our planet, and our lives depends on it. And if we have a healthy ocean, we'll have a healthy future. Simple as that. But right now, just like Titanic, we're steaming full speed into the night, into the darkness, not knowing what lies ahead, and that's a big mistake.
Well, thank you, David. I mean, that was great, and you know, hopefully there will be many, many more films also made about the ocean, and using film as a medium for people to kind of just gasp in awe to kind of the marvels of what's happening over there. We also hope to have at Imagine Science like a whole series about the oceans, and you know, and in many ways, you know, you don't even need to narrate it. It's just so beautiful, and you know, some of the videos of the camouflage and all that have been just amazing, and it's amazing to see how it goes viral. So,
Yep.
but thank you so much. After all those little glitches we had initially, we made it work, and I can't thank you enough. I hope to see you at Imagine Science, you know,
You
this
will.
year or the upcoming years, and thank you so much.
Thanks, Alexis. Take care.
Okay, take care. Bye bye. Bye bye.
Bye-bye.